In this video, we'll introduce the wattmeter, and then we'll further explore how to use it in three-phase systems. So we've used voltmeters and we've used ammeters. What a wattmeter is going to do is going to measure power. So let's look at a traditional wattmeter. Traditionally, it was an electrodynamic device or an electrodynamometer instrument. So what it had was rotating coils, and this rotating potential coil had many turns. It was a heavy coil, so that and highly resistive coil, so not much current would flow through it. And the current coil was fixed. It was fixed in place, but it would have a very low resistance. What the way the power was measured, since this potential coil could move, it used the torque on this moving coil. So the torque is going to be proportional to the product of the voltage and current, and therefore it's going to be proportional to the instantaneous power. But the inertia, when that is torquing, is going to average that out. So that averages the torque, so you end up with the average power. So the scale of this has to be calibrated, since what the torque has a moving needle on it, and that needle where it ends up is going to depend on the position. So this device had to be calibrated, and also being an analog device, it couldn't measure negative power. A solid state wattmeter is going to use op amps. It's going to use a multiplier circuit to multiply the current and voltage signals, and then it'll use an integrator to perform the averaging. So again, if we go back and look at the old coil made, the old wattmeter, an old wattmeter made with these coils, the current coil is going to be a heavy wire, low resistance, and it's going to measure the current into the network. The potential coil is going to be made of many turns, since it needs many turns, it will be long, but it'll be a very fine wire so that it has high resistance and reduces the actual flow of current through there. And that wattmeter is designed to measure power. So if it's designed to measure power, if this is a passive network, it wants to measure the power absorbed. So this is in fact set up to measure power absorbed, because this plus sign shows the current flowing in this direction towards the plus sign. So this is going to measure current flowing into current in this direction, and then we see the plus on the voltage coil, and that's going to measure plus or minus V in this direction. So we have current flowing out of the positive voltage terminal relative to this. So it would measure the power absorbed. However, if what happened is if our needle, again, this is an analog device, so if the needle gets pegged low, what we have to do is then flip the potential cable. So what we just do is flip, this is a movable terminals, so we'd flip them so that the positive was in fact on this side, and then plus or minus V, and then we'd be able to measure the power being supplied by the network. And that would be, of course, given that this network wasn't passive, that was a lie. All right, so again, our analog wattmeter, the torque on the system and the needle is proportional to our instantaneous power. The mechanical inertia then is going to average that and cause that deflection to be proportional to the average of the torque. So the average of the torque will give us our power being the effective voltage times the effective current times the cosine theta V minus Vi. That's our average power formula for AC sinusoidal steady state. So our wattmeter itself is going to have 4 terminals. It's going to give us an upscale reading if the current flows into the positive terminal of the coil, while the potential, with respect to a positive voltage at the potential coil. So how you set up the coils is going to depend upon whether you want to measure power absorbed or power delivered. So this is set up to measure the power absorbed. So if we look at this, an example within a circuit, so our wattmeter symbol is a little more dramatic than our voltmeter or ammeter symbol, but it does have the positive reference, show the positive side of this is basically an ammeter and a voltmeter, the positive side of the ammeter and the positive side of the voltmeter. And so this asks us to to measure the power absorbed. What will it measure? Well, it's going to measure the voltage across the potential coil. So that's V2. We're given V2 here. And it's going to measure the current through this 10 ohm resistor, because then it's going to be in series with our current coil. We have a theta V2, that's 0 degrees, so we just need that current phasor, the magnitude and the angle. So if we want if we're asked what is it going to measure, then we want to analyze this circuit. So we can analyze the circuit. We can analyze it with a mesh analysis. We can analyze it using superposition, right? We could short out this voltage source. We have 10 ohms in parallel with J5. And then our current would be flowing in the opposite direction. It would just be 100 divided by 10 plus 10 ohms in parallel with J5. And then short out this terminal over here and just get the volt again, the current through this I, and sum the two. Or we could do a mesh analysis is easy to do there. So but what we need to find is the current. So once we find that current using superposition or mesh to solve for the current, I'll leave that up to you to do. That current is going to be 11. You should find that current to be 11.18. And I don't have units there. So this is going to be amps. And it's, even though, we're assuming here again RMS. And so this would be an amp RMS. So then we can calculate our power, the product of the voltage magnitude, product of the current magnitude, and the cosine of the difference between the angles. And so what we do get, since this angle is negative 153.4 degrees, we end up with a negative reading. So what that tells us is we're not going to be able to measure it with an analog wattmeter. So what we would have to do is we would have to flip these terminals. We'd have to eliminate that, and we have to flip it. Essentially, we'd flip these two cables just like we would with a regular voltmeter. And then we would get this reading to then read positive 1,000 watts, and it would be so what we'd find is that this voltage source here is in fact delivering 1,000 watts of power. If we wanted to measure the power being delivered or supplied by, well, it's going to be absorbed by this one, we would put the wattmeter, put the voltage cables there and the current cable in there. All right, so that's our introduction to wattmeters. In the next video, we will look at how we use it in a three-phase system.